Hello everyone, this is Dr. Padmaja, Associate Professor, Institute of Aeronautical Engineering, Hyderabad. In this video, we are going to learn a number of problems using fast and slow pointer approach. Now, first of all, we should understand what do you mean by fast and slow pointer approach. Now, in computer programming, if you are solving any problem using two-pointer approach where one pointer moves slowly and another pointer moves fast. That means it is also known as a hare and tortoise approach, where if tortoise is moving by one step and hare is moving by two steps, for example, then we will say that it is a fast and slow pointer approach. Means both the pointers will start from a particular starting point, but every time they have to make different steps. So one will go slowly, one will go fast. So this is called fast and slow pointer approach. Now, there are a number of problems which can be solved easily with less time complexity and space complexity using fast and slow pointer approach. Now, today we are going to discuss some of the problems which can be solved using this particular approach. Now, the first problem that we are going to discuss is called middle of the linked list. Now, let us understand the question first. Given the head of the linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. That means if you have given a linked list, head contains the address of the first node. Suppose there are 5 nodes in the linked list, that is there are odd number of nodes. Then odd number of nodes are there. Then there will be exactly one middle node. This is the middle node. If there are even number of nodes, as given in the second test case, 1 to 6, there are even number of nodes, then there are two middle nodes. This is the first middle node and this is the second middle node. So, the question is given to return the second middle node, that is 4. Okay, and what it is given that you have to return the middle node of the linked list. Okay, so we will return in the even number of nodes, we will return the second middle node. In the odd number of nodes, we will return exactly the middle node in the linked list. Now, after understanding the question with the test cases, let us see how to solve this problem using fast and slow pointer approach. Now, let us take the first test case, that is, we have a head pointer and we have 5 nodes. So, every node contains a data value and address of the next node. Suppose the address of the first node is 100, head will point to 100, that is to the first node. Okay, first node contains the address of second node, second contains the address of third node, and this way a single linked list is formed. So, in the last node, the address part will be null. To indicate that this is the last node, the address part will be null. Okay. Now, so this is your node 1, this is your node 2, this is your node 3, node 4, and so on, node 5. There are 5 nodes, right? Now, what we will do, without disturbing the head pointer, we will take slow and fast pointer approach, where slow is a pointer and fast is pointer. Both will start from the beginning. So, slow and fast both will contain the address 100. That is, slow is also pointing to first node, fast is also pointing to the first node. So, you can understand this by writing the code like this: slow is equal to fast is equal to head. That means both the pointers will start from the beginning of the linked list. Right. Now, as the approach says that one will go slowly, another will go fast. That means if slow will make a move of one step, fast will make 2 steps. Okay. Now, while the address what is there in the fast contains how much? 100. Is it a null address? No. And fast of next, 100's next is what? 200. 200 is also not a null address? Yes. So, both the conditions are true. If this is true, then make slow to slow of next. Now slope will be changed to 200. That means now slope is pointing to the second node. And fast is equal to fast up next up next. So fast up next is 200. 200's next is 300. Now fast is pointing to third node. Hope it is clear. Now next time. 300 fast is 300 is not equals to none. No, it is a valid address too. And fast of next 300's next is how much? 400. It is not equals to none. Yes, it is not equals to none. So both are true. So when it is true, again move fast and slow. Now slow becomes slow of next node. Slow becomes 300. Now slow is pointing to the third node and fast is pointing to the 500. So fast is fast up next up next. So fast is 500. Now check the condition in the loop again. Now what is the value of fast? 500. 500 is not equals to none. Yes, it is a valid address. But 500's next is a null address because 500's next is null address. So the condition becomes false now. So when this loop is false, at that time, slow contains or slow points to the address of the middle node. Okay, so we have to return the middle node. So middle node's address is contained by slow pointer. So you have seen this how nicely slow and fast pointer through the slow and fast pointer approach. When the fast approaches to the last node or the fast pointer reaches to the last node, slow pointer is exactly at the middle node. So this is slow and fast is here. So using this approach, we have easily identified which is the middle of the linked list. So you can try another test case with 6 nodes and you will find that when fast reaches to the last node, slow will be exactly at the second middle node. Okay, so this is the answer of this middle of the linked list question using slow and fast pointer approach. Hope everybody might have understood. Now let us move on to the next question using slow and fast pointer approach. Now, the second question that we are going to discuss using slow and fast pointer approach is linked list cycle. Let us understand the question first. Given head, the head of the linked list, determine if the linked list has a cycle in it. When you will say the linked list has a cycle, linked list, there is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. That means you start from any point, again you can reach to that point, then we'll say that it is having a cycle in it. Now, here the variable position, internally, the position is used to denote the index of the node that the tail's next pointer is connected to. So, here position is equal to 1, that means this is the last node, okay, or the tail node's next pointer is containing exactly pointing to this particular node. But there is a note given here that the position is not passed as a parameter. That means while writing the code, you should not use position as a parameter and solve this problem. So position is just an information given that the position from where it has started or the last tail's node's pointer is connected to that particular position. It is just an information, additional information given in the question, but you should not use it as a parameter while writing the code. Right? Now, what you have to return from this problem? You have to return true if there is a cycle in the linked list. Otherwise, you have to return false. Okay. See the second test case. So, in the first test case, the head node is pointing to the node number 3. So, there are 4 nodes in the linked list, 3, 2, 0 and -4 as you can see in this diagram. And position is equal to 1. That means there is a cycle from node 1. So, there is a cycle from node 1. So, if you will start from, so this is your head node. Head is pointing to the first node, but there is a cycle back to the position number 1 node. Right. So, there is a cycle. Yes, there is a cycle. So, if you see the second one, the head node is pointing to the first node. Okay. And there is a cycle from position number 0 itself. That means there is a cycle like this. So, in the third case, so we will return true here. And in the third case, the head pointer is pointing to this node. So there is only one node. So this node is not pointing to itself. It is a null address. That's why there is no cycle. So here position is equal to -1, where there is no cycle in the linked list. So answer is equal to false over here. Right? Hope the question is understood, but we should answer this question using slow and fast pointer approach. Let us understand how to use slow and fast pointer approach. Now, we'll take the example here 3, 2, 0 and -4. So let us draw a linked list first. So in the linked list, there is a head pointer and there are 4 nodes like this: 3, 2, 0 and -4. Okay. Now, suppose the addresses are 100, 200, 300 and 400. Okay. Head contains 100. Always it points to the first node. First node contains 200. So it is pointing to second node. It contains 300. It points to third node. It contains 400. It is pointing to the fourth. But tail node, this is the tail node. It contains your 200. That means it points to this node again. Right? This is the linked list you have drawn. Right. So head is given to you. Head is passed as a parameter. What is the value of it? It is 100. What you have to return? The return type is true or false. Okay, it's a boolean value, which is either if there is a cycle, it will return true. If there is no cycle, it will return false. Right. Now, as we have to solve using slow and fast pointer approach, let us take 2 pointers. One is slow and one is fast. Initially, slow is equal to 100 and fast is equal to 100. That means slow and fast both are pointing to the first node. Right? This is the statement we understood. Now, how far you have to traverse? So, when you will say that the linked list is having a cycle. So, for that reason, we are implementing here internally. There is an algorithm called Floyd's cycle detection algorithm. This algorithm says that using the slow and fast pointer approach, we'll start traversing from the beginning of the linked list, and after some iterations, when slow pointer meets fast pointer again, that means if they coincide at a particular point, then we'll say that the linked list is having a cycle in it. This is the Floyd cycle detection algorithm. This particular algorithm we are going to use. Okay. So how to use this Floyd cycle detection algorithm? Let us understand through this code. Now, initially slow is equal to 100, fast is equal to 100. Both are pointing to the first. Now, while fast, what is the value of fast? Fast value is 100, which is a valid address. Now, fast up next is how much? 100's next is 200, which is also a valid address. So, when both are valid address, then this loop becomes true. Now, move the slow pointer by one step. So, slow becomes slow of next. Now, what will be the value of slow? Slow becomes 200. Okay, it is changed to 200. It is now pointing to second node. And fast becomes how much? Slow. Fast up next. So, it becomes 300. Okay, now it becomes 300. It is pointing to the third node. Right? Now, is it slow is equal to fast? The addresses are same. Are they pointing to the same node? No. 200 is equal to 300? No. So, again go to the loop. Okay. Fast. What is the value of fast? 300. Is it a valid address? Yes. What is the value of fast up next? 300's next is how much? 400. Is it a valid address? Yes. Then, what you will do? Slow move by one step. Slow is equal to 300. Fast is equal to how much? Fast up next is 400. 400's next is 200. Now, fast becomes 200. Okay. Now, slow is equal to fast again. 300 is equal to 200. Are they same address? Are they referring to or pointing to the same node? No. Again, go to the loop. Fast. What is the value of fast? 200. Is it a valid address? Yes. Fast up next. 200's next is how much? 300. Is it a valid address? Yes. So, loop condition is true. Now, slow is equal to slow of next. So, 300 next is 400. Slow is pointing to 400. What about fast? Fast up next is 200. 200's next is 300. 300's next is 400. Now slow is equal to fast? Yes. Now slow and fast both are pointing to this particular node. Now, what fluid cycle detection algorithm says? That when slow and fast pointer will meet at a particular point, then we'll say that linked list is having a cycle. So according to that condition, we will return true. So if they do not meet during all the iterations, if you do, then we'll say that there is no cycle in it. So we'll return false. Okay. So I hope it is understood how to detect a cycle in a linked list using fast and slow pointer approach or hare and tortoise approach. Now, let us understand another problem that is called remove nth node from the end of the list. Now, this problem also we are going to solve using the slow and fast pointer approach. Let us understand the question first. Given the head of the linked list, remove the nth node from the end of the list and return its head. Now, if you consider this is the head of the linked list, head is always containing the address of the first node. Suppose this is 100, this is 200, this is 300, this is 400 and this is 500. Okay, head contains 1, 2, 3, 4, 5 means there are 5 nodes. Head contains, head is pointing to the first node. N is equal to 2. It has told to remove the nth node from the end of the list. So from the end of the list, this is the N is equal to 2. This node we have to delete. Now return the head. If this node is deleted, then the third node will point to the fifth node. Okay, third node must contain the address of the fifth node. Then we will say that this node is detached. Now we have to return the linked list. Return the head of, return its head. So head means we will return the linked list head. This is the first test case. In the second test case, there is only one node. So we have head here and there is only one node. Okay, if it is 100, if it is 100. So one node means the address part will be null. If n is equal to 1 from the end, this node has to be deleted. This node has to be deleted. Then what head will contain? Head will contain a null address after deletion. Right? So we have to return head is equal to empty. Right? If third test case, if head is containing means the linked list is having 2 nodes, 1 and 2, then it is 200, this is 100, this is 200, this is null, this is 100. Right? This is the linked list. N is equal to 1 they have told. So from the end n is equal to 1, this node will have to delete. Then what will happen? There is no change to head. Only this address part will be changed to null. This part will be changed to none. Otherwise there is no change to head. So return head means only 1 will be there. So I hope this question is understood that how to remove the nth node from the list. So let us write down the code to satisfy all the test cases given in the question. So how to write down the code in Python? Now we'll go with the first test case, that is this is head, okay, containing 5 nodes, 1, 2, 3, 4 and 5. So let us say the addresses are 100, 200, 300, 400 and 500. So this is 100, right? Now using slow and fast pointer approach you have to do. So what you will do? Initially slow is equal to fast is equal to head. Because in a single linked list, we have to start always from the beginning. So slow is equal to 100, fast is equal to also 100. Both are pointing to the first. Right? Now, the nth node from the end you have to delete. So the logic is first keep your fast pointer at the nth node. Means take up to nth node. So what we will do? We'll write out a simple for loop for I in the range of n. What is the value of n? In the first test case, n value is 2. N value is 2 is given. So last from the end second node you have to delete. So n is equal to 2. So this loop is going to run 2 times for 0 and 1. For I value 0 and 1. For I value 0, fast I have to update to fast of next, so it becomes 200. Again for I is equal to 1, it will update to 300. That means when this loop is over, my fast pointer is here and my slow pointer is here. Right? Now, the second part of the code is if there is only one node, if the situation is like this, if head is there and there is only one node. Okay? So this is 100, this is 100. If not fast, okay? If not fast means what will happen if there is only one node and that node I have to delete. If n is equal to 1, if n is equal to 1 suppose, then this loop is going to run one time. So fast is equal to initially 100. Fast of next is how much? Null. So fast becomes none. If not fast, if fast is not none, if fast is none, then return next head of next. Head of next is how much? This node's next part is none, right? So head of next, head becomes null. To indicate that once the node is deleted, head should be none. Head should be empty. So this is the code written to satisfy the test case if there is one node. If there is one node. This way you have to write because head should be empty. Right. Otherwise, let us understand this previous first test case only where n is equal to 2 and this node we have to delete. Right. So when this loop is over, fast is pointing to the third node and slow is pointing to the first node. Right. While fast of next 300's next is how much? 400. Is it a valid address? Yes. Then move slow by one step, fast by one step. Already fast is ahead of slow. Okay. So slow is slow up next means now slow is coming here. Right. Fast is going by one more step. So fast is pointing here. Right. Next time. Fast is now 400. 400 next is how much? 500. Is it a valid address? Yes. Slow is equal to slow up next. So now slow is pointing here. And fast is pointing here. Now we have reached to the end of the linked list. Now when fast of next 500's next is none. So this loop is going to stop. So when this loop is going to stop, slow is exactly pointing to the node which you want to delete and fast is at the end of the linked list. Okay. Now what you will do? Deleting a node means connecting the node which is pointed by slow to the node which is pointed by fast. So you have to connect third node to the fifth node. How will you do it? So we'll write down like this. Slow dot next is equal to slow dot next dot next. Slow dot next is how much? 400. 400's next is 500. So in the third node, we are going to store 500, which is the address of the last. So with this, the new connection is established like this, and this address means this node is detached. So when this node is detached, logically we will say that the node is removed from the linked list. Okay. So finally, what is asked in the question? To return the head of the linked list. Okay. Now to all these solutions, you have to just attach the driver code and call the method and you have to run it and check the solution. Now, I hope the slow and fast pointer approach is understood. In this video, we have discussed 3 problems using slow and fast pointer approach. Thank you so much for understanding and applying the slow and fast pointer approach for solving problems. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.